Greetings, students, and welcome to this section of the basic chemistry series. We already have two videos on this, and if you haven't gone through the two previous videos, go through them before coming to this one so that you can understand better. Welcome once again. Before we begin, if you are visiting this channel for the first time and you have not subscribed to this channel, click on that subscribe button there and then click on that bell icon close to it so that you can turn on the notifications and be able to get informed anytime we post a video. Now, welcome back. In this section, we'll quickly discuss valency. Some of you in your JS3, you were taught valency. So we'll quickly look at this subject and then see how you'll be able to understand it very well. Fine. Now, before we begin, let me do a quick review, just within 10 seconds, of KLMN, electronic configuration. Let me pick oxygen. Oxygen is number 8. I taught you in the previous video that you do 1, 2, 3, 4, 5, 6, 7, 8. Right? Now, pay good attention to this, because this is your foundation in chemistry as a science student and as an SS1 student. Okay? Remember that I told you this shell takes a maximum of 8 electrons. This number 1 shell takes a maximum of 2 electrons. Any other shell outside takes 8 as far as the first 20 elements are concerned. Now, there's a law in chemistry that says that the last shell, this last shell is called the outermost shell. The law in chemistry, it states that the outermost shell of every element must be completed. I repeat it. The outermost shell of every element must be completed. There are 3 laws I will state for you. One is that the outermost shell of every element must be completed. For example, look at this one now. It has 1, 2, 3, 4, 5, 6. It needs 2 to complete this shell. It's not complete. And according to this law I quoted now, it must be completed. It's a must. Now, how will an element complete its last shell, which is the outermost shell? How? If the law of chemistry says that the outermost shell, which is the last shell, must be completed, how? This oxygen now, we have done the K element, it needs 2. So how will it complete it? Now, the second law now says, if the number of electrons you as an element will need to complete your last shell, if it is less than 5, you can borrow it from another element. But if the number is up to 5, if the number you need is up to 5, something is going to happen now. Let's look at it this way. Let me bring up another element so that we'll use the tool to study it. Let's look at sodium. Sodium is 1, 2. Sodium is number 11. Take note. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now let us look at these two men here. Let's study. Okay? This one needs, remember what I said, the last shell must be complete. This one needs 2 here to complete it to be 8. The last shell is complete when it is up to 8. But if it's this first shell, it needs only 2. Okay, so let's take it up from there. This one needs 2 to complete the shell as ordered by chemistry. This one has 1 in the last shell. That means it even needs 1, 2, 3, 4, 5, 6, 7. It needs 7 to make it 8, which is complete to be complete. Are you following? So that second law I put it, I said, if an element needs less than 5 electrons to complete that last one, it will go and borrow it from another element and be complete. But if an element needs 5 electrons or more than 5, it can borrow. You cannot borrow anything more than 4. Are you following? So if this man that needs 7 electrons to complete this shell cannot get 7, what will he now do? And the law of chemistry says you must complete the shell. Now see what he's going to do. Meanwhile, let's finish this one first. This one will need 2, but he can get 2 and it will be fine because it's less than 5, right? That one, you've understood that one. This one that needs 7 cannot get 7 because it's already up to 5 or more than 5. Anything 5 or more than 5, you can't get it. Now, the law of chemistry now says, if you cannot complete it because you need up to 5 or more than 5, if you can't get it, complete it. You see this shell that is here that you cannot complete, but carry this electron that you cannot complete, dash it to somebody, just dash it out, and throw away the shell. But the last shell must be complete. So if you cannot complete the last shell by borrowing, because you need up to 5 electrons or more than 5 electrons, what are you going to do? That one that you cannot complete, give it out. Are you following me now? So it means that this guy needs 2 electrons. He can get 2. This guy needs 7 electrons. He can't get 7. So what it will do now is this one that it cannot complete, it will carry it and dash somebody. So it will now clean this last shell, so that it will use this one to be complete. Are you following now? So summary number 1 is that the last shell must be complete. 2, no element can borrow more than 4 to be complete. Okay, so you borrow 4 or less, which is less than 5. 3, if an element needs more than 4, that is 5 and above, to complete the last shell, he can't get it. So what is he going to do? It will give out that one that is not complete and dash it out. Okay. Now I want to make some final explanations before I now define valency, and then we'll round off this series. Okay. Now let me come back here. Let me bring it back. When an element is able to complete its last shell, we say that the element is now stable, or that the element has attained what we call the octet structure. Octet structure or duplet structure. So we have octet structure or duplet structure. Are you following now? Octet or duplet. Octet means if you complete it to be 8, it's octet. If it's this one that you complete now, it will be duplet. Something like hydrogen now. Look at hydrogen. Hydrogen is just 1, right? How many does it need to complete the last shell? Remember that the first shell contains only 2. So it just needs only 1 to complete this. So you can get 1. You see it? So if he borrows 1 and completes this, it means it has attained the duplet structure. Duplet means 2. But if this guy that needs 2 now borrows 2 and completes this, he has made it 8 now. He has attained the octet structure. I hope you are following. So now let us summarize. So oxygen needs 2 to complete the last shell. I believe you have understood it. This one needs 7. This one cannot get 7 because it's already more than 4. So it's going to give out 1. This one is going to accept 2. That makes this sodium it makes this sodium a donor and makes this oxygen an acceptor. So what you are going to learn in this video, you should be able to identify whether an element is a donor or an acceptor. Are you following? This one is an acceptor because it is accepting 2. This one is a donor because it's giving out 1 since it cannot get 7. Okay? So take note of that. Now, with what we have explained, let me also touch one more thing. Let me touch this. Please pay attention to this. Let's pick phosphorus. Let's pick phosphorus. Phosphorus is number 15. So let's do the K element and look at it. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's complete now. So we now have remaining 5, 11, 12, 13, 14, 15. Are you following? Now let me ask you, how many does this, according to the law of chemistry I explained, how many electrons does this phosphorus need to complete the last shell? How many? Let us count. Remember it's 8, but 1, 2, 3, 4, 5. It needs 1, 2, 3. It needs 3. Can it get 3? Yes, it can, because it's less than 5. Can get 3, yes. So if it's accepting 3 now, it means that this guy is what? An acceptor. Are you following? And then finally, let's look at calcium. Calcium is number 20. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, right? Now how many does it need to complete this last shell? It needs, we have 1, 2 here. It needs 1, 2, 3, 4, 5, 6. Can it get 6? No. Because 6 is already more than 4. You can't get more than 4. So what's it going to do? Like I explained, it will carry these 2 and dash it out and carry this shell, throw it away. So this one is a donor. So I believe with this explanation, you know when an element is a donor and when an element is what? An acceptor, right? Now let's now define our topic. I have taken time to explain this because this is your foundation in chemistry. So you listen to it very well. Now let's now define valency. Valency is defined as the combining power of an element. By theory, it is the combining power of an element. But I want you to take this thing I'm going to say down. Valency is the number of electrons an element gains or loses in order to attain the octet structure or duplet structure, or in order to be stable. I repeat, valency is the number of electrons gained or lost by an element in order to attain the octet structure or duplet structure, or in order to be stable. They are all the same thing. Now, let's take for example, now let's take it one by one. Number 1, we are starting the analysis now. Hydrogen is number 1, right? Let's do the K element and look at it. So we have 1, your nucleus is here. How many does it need to complete this last shell? Remember that the last shell contains only 2. That means hydrogen needs only 1 to complete this last shell because the first shell takes only 2. Hydrogen needs 1. Can it get 1? Yes, because it's less than 5. So what is valency of hydrogen? It means that the valency is equal to 1 because it can accept 1. It accepts 1 electron to be complete. Is it clear? Let's look at the next one. Helium. Helium is 2, 2, 1, 2. What do you say about this helium now? Helium is, remember that this first shell contains only 2 electrons. That means helium is complete. It doesn't need any electron. It's complete. Therefore, the valency of helium is what? 0. You know why it is 0? It is not accepting anything. It's already complete. Now, number 3. Let me jump it to magnesium. Magnesium is number 12. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What about this one? It needs 1, 2, 3, 4, 5, 6, right? Can we get 6? No, it's already more than 4. So it's going to, these 2 now is going to throw it, give it out. So it means that it is losing 2 electrons now. And remember what I said, valency is number of electrons you lose or gain. So since it's losing 2, because it cannot complete it, the valency becomes is 2, and then it is a donor. Is it clear? Then let's talk about this one. Let's do neon. Neon. What is neon? Number 10, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What do you say about neon? Neon is complete. It doesn't need anything. It is complete. It doesn't need anything. What do you now say about the valency? The valency will be 0 because it's not gaining anything. So the valency is 0. Okay? It's not gaining anything. Alright? So it is not a donor, it is not an acceptor because it's not gaining, it is not losing. Okay? Now, one more. Okay, let's just do 2 more examples, then we'll round off the video. Number 4, rather number 5. Let's talk about aluminium. Aluminium is my 13, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. How many does he need to complete the last shell? He needs 1, 2, 3, 4, 5. Can he get 5? No, it's already more than 4. What happens? He's going to carry this 3 that I cannot complete and give it out and throw away this shell. So it's a donor. He's giving out 3. And the number he's giving out is the valency. The number you're gaining or giving out is the valency. So since he's giving out 3, the valency becomes 3 and it is a donor. I hope you're following it. Okay, finally now, let's finish it up. Let's take one more example and round off. The 4th one, the 6th one, let's talk about sulfur. Sulfur is number 16. So we do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's 16 now. How many does he need to complete the last shell? He needs just 2. Can he get 2? Yes, because it's less than 5. Okay, so if he gets 2 now, the valency becomes 2. Okay, and then it is an acceptor. So anytime you do the K element of an element, check the number of electrons he needs in the last shell to know whether he's going to gain to complete it or give out since he cannot complete it. So summary is that the key points I want us to take from this video. Number 1, I've told you how to know whether an element is a donor or an acceptor. Number 1, I've taught you how to get valency. That valency is the number of electrons an element will give out or gain to attain the octet structure or duplex structure or to be stable. Then I've explained also to you how to know when an element is a donor or an acceptor. Okay, so as the assignment I'm going to give you now is that go and do the first 20 elements from hydrogen to calcium. Find all their valencies. First do their K elements, then find all their valencies. Is it clear? So that's the end of the video. If you have learned something from this video and you have not subscribed to this channel, please click on that subscribe button there that is facing you. Then there's a bell icon there also tap on it so that when we post any video or next video, you'll be notified. So thank you for coming around. I will see you in the next video.